Welcome to this short video on how to calculate the gradient of distance vector 1 by r. So let us consider a point P having the coordinates x dash, y dash and z dash, or x bar, y bar, z bar, which is at a distance of r meter away from the origin. Let's say the coordinates of the origin is x, y, z. So as per the distance formula, r can be calculated by the equation x minus x bar the whole square plus y minus y bar the whole square plus z minus z bar the whole square. Now this is our scenario where we have the point x, y, z and x dash, y dash, z dash. Let us assume that this particular vector will be in the direction away from the x, y, z, and it is towards the point P. So r vector is always the direction which is away from this x, y, z coordinates, and it is towards x dash, y dash and z dash. And accordingly we can get the equation of the vector r vector is equal to x bar minus xi plus y bar minus yj and z bar minus zk. Now what is our main purpose is to calculate or to require to evaluate del of 1 by r, and as we know this is the partial differential operator which is given by partial of x of I plus partial of yj plus partial z of k. Now we can rewrite the equation in this form. Del of 1 by r is equal to partial of x of I plus partial of y of j plus partial of z of k times x minus x bar whole square plus y minus y bar whole square plus z minus z bar whole square to the power minus half, because we are interested in 1 by r. Now this equation they can be further extended as, if you just distribute the x part, y part and z part, then we will have an equation like this: partial of x with respect to the whole term, then with the direction I, partial of y with respect to the whole term in the direction of j, and partial of z with respect to the whole term in the direction of k. Let us try to divide the whole equation into three segments. The first segment is A, which is with respect to x. Second segment is B with respect to y. And the third segment is C, which is the partial differentiation with respect to z. So if you consider the part A, which is the partial differentiation with respect to x, then we will have an equation something like this. As we know that partial differentiation of x raised to n is nx raised to n minus 1. In this case it is minus half. So minus half the whole term, which is x minus x bar whole square, etc., to the power minus half minus 1, which is minus 3 by 2. Then we have to look at the term inside the bracket. Since this particular function we are going to differentiate with respect to x, then we are supposed to find the differentiation of this particular term, which is x minus x bar whole square. And if you try to take the differentiation of x minus x bar whole square, we will get 2 into x minus x bar, then the distance vector, which is I. Similarly, if you try to find the corresponding value with respect to y and z, we will have, so then we will have the following terms with respect to partial differentiation of the whole term with respect to y. We will have this equation, because the first term is going to be the same. The second term will have y minus y bar, and the third is, for the third case, when the c part where we are going to differentiate with respect to z, we have the first term is going to be the same, but the second term is going to be z minus z bar. This can be further simplified as follows. So we will have the following term. So the term A become minus of x minus x bar I divided by the whole equation, which is x minus x bar whole square plus y minus y bar whole square plus z minus z bar whole square to the power 3 by 2. Same way, B will be the same. denominator is same, but only the numerator is minus y bar j. And for the third term c, which is denominator again going to be the same, the numerator will be minus z bar k. We will try to combine these three equations together. So now we have, when we combine all these three equations, we got minus of x minus x bar I plus y minus y bar j and z minus z bar k divided by, we have the same numerator with a power of 3 by 2. And if you see the denominator, which is the whole term with to the power 3 by 2, the term within the bracket is nothing but r square, because x minus x bar whole square plus y minus y bar whole square plus z minus z bar whole square is going to be r square. So if you expand this particular, if you simplify this particular term, or if you substitute the term within the bracket is equal to r, then we will r square, then we will have r to the power 3, we will get r to the power 3. And we already mentioned that x minus x bar whole square plus y minus y bar whole square plus z minus z bar whole square, that will give you the magnitude of r square. So the whole term within the bracket is going to be r square. So if I am going to replace this term by r square, then the whole term the denominator become r cube. And if you see the numerator, which is x minus x bar I, y minus y bar j and z minus z bar k with a minus sign. And in the beginning of the lecture, we have mentioned that x bar minus xi plus y bar minus yj, z bar minus zk, that is equal to r vector. So this one, related to this one, it is a matter of 1 minus sign. So this equation is nothing but negative of this. In other words, the answer is going to be plus r. Already there is a minus, but this in the equation it is available in a flip manner. So if you substitute that minus r vector here, then that minus and minus is making is plus r and divided by r cube. As we know that any vector that can be represented as magnitude of the vector multiplied by the unit vector divided by r cube. So if you simplify this equation, we will get the result 1 by r square into ar cap. The final answer is del of 1 by r is equal to 1 by r square, 1 by r square, then ar cap, where ar cap is nothing but the unit vector which indicate direction of the radius vector. And magnitude of, the absolute value of r indicate magnitude of r. So this is the final equation. Thank you for watching.